So this chapter, they switched things a little bit around for this class, but it used to be, it was a little bit more open on like what you could choose to pick, but this was like the one chapter that they like really required the class to take. So I'm not exactly sure why they decided that. I wasn't in the committee or decision to do that. But if I had to guess, it's like this is probably one of the more practical sort of things that you will probably use throughout your life. With that said, I'm not an accountant and I'm not like a big into actuarial math or anything like that. To me, like accounting stuff is like one of the least fun things in math, but I also prefer the logic and y'all probably don't prefer the logic. So with that said, like part of the reason is because all this is by the book. It's by a formula. If you understand what the question is asking, like basically you're plugging and chugging stuff into a formula. And so I would say that's why it's not one of my favorite parts, is because it's not a lot of like critical thinking. It's a lot of like, what is this question asking? And let me throw it into a formula sort of stuff. With that said, hopefully you've looked over 4A and 4B. So in 4A, it was just basically the one thing that you should really probably kind of take away from 4A, besides this thing is blurry. Let's fix this up a little bit. The one thing you should really take away from 4A is converting things to monthly finances. So doing a monthly sort of budget. So I believe the first couple problems off of here are all about doing that sort of thing. So if we're looking at interest payments, find the monthly interest payment in each of the following situations. When an annual rate is given, assume that monthly interest rates are 1/12 of annual interest rates. So just a quick recap, 4A was all about like personal finances, finding those monthly budgets. And then there's a few insurance problems, health insurance problems. Then 4B, we're going to talk about interest. And there are two different types of sort of interest that we were taking in 4B. One of them is simple interest, and the other one is compound interest. And then with compounding, there's some options of how many times we compound it. So we start off with compounding once a year, and then we started with compounding more than one time per year. And then we got down to compounding it like infinitesimally many times per year, which we referred to as continuously compounding. So we have formulas for each of these things. There were at least like 3 formulas in 4B, I think. So with that said, I'm not expecting you to memorize formulas. If there's a formula, I will probably most likely throw it out at you. I'm not trying to get you to memorize formulas, but you do have to know like what the parts of the formula mean, what the variables in the formula mean. You have to be familiar with the formula at the very least. Can't see nothing when I'm looking at my participants. Close that. There we go. So what does this say? You maintain an average balance of $750 on your credit card. And so our goal was to find the monthly interest rate on this thing. So it is an 18% annual interest rate. So if it's an 18% annual interest rate, how do I convert this annual interest rate into a monthly interest rate? This is my question. So first off, I'm going to say 18 decimal, so 0.18.
Divide it by 12.
Divide it by 12. There are 12 months in a year. So if we want to make it go from annual to monthly, we have to divide by 12. So I know a lot of these things, like I would do unit analysis or something like that for it. In this section, I'm probably just going to divide by 12, multiply by 4, and like try to do things the short, simple way. Make it a little sweeter. And I'm doing 18% divided by 12. This is going to be my monthly rate, and I'm going to take this on what amount? There's one other sort of thing I really need to do. What am I taking that 18% on?
750.
On the 750 balance. So I do 8.18 divided by 12. This is going to be 0.0. And I multiply multiply that by 750. Okay, so I'm doing this. I should get 1125 for this thing, I believe. Any questions about this one? So basically, we're just converting annual to monthly. And if we want to convert something that's in annual to monthly, we're going to divide by 12. Other than that, I think the setup's pretty straightforward in that one. Prorating. So now we want to prorate things. So this is something pretty common. They'll prorate stuff like if you go and get rent and it's not the beginning of the month, they'll prorate however many days of rent or something like that, right? They'll divide however much you get into however many days you have. So that's kind of what we're doing here. Talib pays a semi-annual premium of $750 for automobile insurance, a monthly premium of $150 for health insurance, and an annual premium of $500 for life insurance. So they want us to convert these to monthly expenses. Are they asking to do it separately? Is that what they're asking? I think they're asking maybe to combine them all. Okay, so if he's paying a semi-annual, what does semi-annual mean? That's a word that maybe we haven't had.
Twice a year.
That's twice a year. So if he's paying this twice a year, he's paying $750 for automobile insurance. How do we prorate that to per month?
Divided by 12.
Divided by, not 12 this time.
6.
If it was a whole year, it would be 12. Since we're doing half a year, this would be 6.
Oh.
So every 6 months, he's going to have to pay $750 is another way to think about it, right? And I think they're adding it in the book. So we could do them separately. I guess we could write them separately. But I think they're just going through and adding these things. So if it's $750 semi-annually, $750 divided by 6, the next thing we see, a monthly premium of $150. So what do I have to do to that? If they're giving it to me monthly, and I want monthly, it's done, right? The other thing is they say an annual premium of what, 500? So I'm taking 500, and what do I divide this thing by?
I guess that's 12. I mean,
That one's the 12, yep. 750 divided by 6. I guess I could do some mill steps in here. 5 plus 150 500 divided by 12 is what, 41.67? So I'm adding 3 numbers together. It should be giving me something like what, 306.67. Is that where I'm at? I'm
Is
off
it
by it.
316 or 306?
It should be 360. What did I do on my calculator? 125 plus, yep, 150. Got it. Typed in the wrong number, so that helps. Yeah, it should be 316. Stone cold. Anyway. So I'm hoping this is something you take away from this chapter. This is something you should be able to do from this chapter, is if they give you something semi-annual and they want to convert it to monthly expense, divide it by 6. If they give it annual, we're going to divide it by the 12 months. If they're giving it to you in monthly, we keep it in monthly. This is kind of the same problem. We're going to convert everything to a monthly expense, and then we're going to subtract the 2. So the following table shows expenses and income of for various individuals. So this is for a single individual. There were multiple tables. This table is for a single individual, but for each person's net monthly cash flow, it may be negative or positive. Assume the amounts shown for salaries and wages are after taxes, and that 1 month is 4 weeks. So right away, if we want to convert this to monthly, this is already in monthly. So we're done with this one. We're done with this one. What about this one right here? If I'm doing $90 a week, how do I convert that to monthly?
Times it by 4.
I got to multiply it by 4. So I'm multiplying this by 4 to get 360 per month. So anytime you see it divided by weeks, or it's per week, you're going to have to multiply it by 4. So that one gets multiplied by 4. You get to multiply by 4. So 25 by 4 is 100 a month. So anything that is not in the per month, we're going to have to convert. So I think there's one other thing to convert here. We're doing what? 420 twice a year? This. We just had something similar to this. If this is happening twice a year, what do I have to do with this amount?
Times
Divided by
2.
6.
I mean, times 12. I mean, twice a year is 6.
Yeah, divide by 6.
Divide by 6.
Or multiply by 4. And if we do 420 divided by 6, okay, so this, it's not too hard to total this one. My total income is going to be $1,900 per month. After I figure out what these charges are per month, the next thing I'm going to want to do is I'm going to want to add them all up to figure out what they add up to. So I'm doing $800 per month. I'm doing $360 per month. I'm doing $125. I'm doing $150. I am doing $70 per month. I am doing $100 per month, and I am doing $400 per month on miscellaneous. So if I did this correctly, hopefully I did. There should be 1, 2, 3, 4, 5, 7 things I'm adding. It should give me 2,000. And what they want to know is net flow. So we want to know our income, we want to know our expenses, and they want to know net cash flow. How do I figure that out? So I do have to write this thing in the right order.
Income minus expenses.
Yep, income. Income is 1,900 minus 2,005. So right away, like if I write it like this, I don't know what that number is, but if you're spending more than you're taking in, that's a pretty good indicator you're going to be negative, right? All right, so if we do this, we should be getting a negative what, 105? I'm talking about dollars, so it's really not like dollars in there. So one way or another, you should indicate that this is a loss. So if you put a negative sign, that's indicating it's a loss. If you tell me there is a loss of $105 per month, that's another way you can tell me. You can tell me verbally, you can tell me with symbolically with the sign, but you have to indicate this is a loss somehow. Are there any questions about this? So if we're going like over a month, if we're going like a year, or we're going like half a year, we're going to end up dividing things, right? If it's below a month, we're going to end up multiplying to get to a month. So being able to convert these expenses that are yearly expenses to monthly expenses, or semi-annual expenses to monthly expenses, this is something I would know how to do. Okay, consider the following situations, which each involve two options. Determine which option is less expenses. Are there unstated factors that might affect your decision? All right, so this is buying a new car, that scenario. So you currently drive 250 miles per week in a car that gets 21 miles per gallon of gas. You're considering buying a new car for $16,000 after the trade-in allowance on your current car, which gets 45 miles per gallon. So the insurance premiums for the new and old car are 800 and 400 euro per year respectively. You anticipate spending 1,500 per year on repairs to the old car, and having no repairs on the new car. Assume that gas costs $3.50 per gallon over a 5-year period. Is it less expensive to keep your old car or buy the new car? So they are giving you a lot of information.
Overload.
But I think there's three things that we need to figure out, right? I think that are going to be different. So if we do our mileage, that's probably one of the biggest things. Figuring out the mileage, figuring out how much these cars are going to cost for the mileage that we're going. These people are driving 250 miles per week. It's a lot. Even for Texas, that's a lot, it seems like. Okay. Assume that gas costs $3.50 per gallon over a 5-year period. Is it less expensive to keep your old car or buy the new car? So there is the mileage problem that we need to figure out here. The other thing is the insurance, and then the other thing is the repairs. So I think those are the three things that are going to be different in price: mileage, insurance, and repairs, right? So I think the insurance and the repairs are kind of straightforward. They give us an amount for the insurance. They give us an amount for the repairs. The thing that we really need to work on and like figure out is that mileage thing, right? So old versus new mileage, how much is it going to cost us? Old versus new, something like that. And we want to figure out the mileage. So if we are driving 250 miles per week, how much is that going to cost us in the old car? So they tell us something about the old car gets 21 miles per gallon. So if we want to figure out how many gallons of gas our old car is using per week, how would we figure that out? For driving 250 miles and it's getting 21 miles per gallon. And this is really where your unit analysis would come in.
You'd put the 21 at the bottom for 1 gallon at the top.
Yeah, so we do. And on top. So now we're figuring out how many gallons my car is using. And if I want to go from gallons, I'm going to do this all in one sort of swoop. So if you want to do this in multiple parts, you absolutely can. But now I'm in gallons and I want to figure out how much money that's going to cost me. They give me gas is $3.50 per gallon. So I'm looking at gallons here. And so this is determining I'm going to need gallons over here. So it's $3.50 for every 1 gallon. Or if you figure out how many gallons your old car needs, multiply that by 350 is another way to say it, right? So this should give me the cost in gas that my old car is costing me. So I'm doing 250. I'm gonna type in the right number times 3.5, and then I got to divide that by 21. So this is not going to be an even number, but it's going to be somewhere around 41.67 in gas. And that is for every week. They wanted us to compare this every, what, 5 years? Yeesh. Okay, so over a 5-year period. So if this is per week, how do I go from per week to year?
Professor, my calculator keeps saying 41.6. So
Yeah, it's
how about-
0.6 repeating, so I rounded it up to 6.7.
Oh, okay.
Times it by 52 and then times it by 5.
Yep. So we would multiply this by 52 to get to the next thing, which is what, 21.66.67. Woo. 21.66. And that would be per year. And then multiply this by 5 to get the 10.833.33. So I could do this with unit analysis. I know I'm going probably a little quicker. Just multiplying by the conversion factor. Okay, so there's mileage. It's going to cost this much in mileage. It's going to cost. The other thing I have is insurance and repairs. So it's going to cost 10.833 for 5 years in gas. The other thing I have is insurance. My insurance for my old car is $800 per year. If I'm talking about $800 per year, I don't want to spend a whole lot of time, but I do 800 and I do that 5 times. It's going to give me 4,000 for 5 years. Okay. And then the one last thing we got to figure out, we got mileage, we got insurance. The last thing they talk about is repairs. So blah, 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 anticipate $1,500 per year on repairs for the old car. So if we're doing $1,500 for a year, we're going to multiply that by 5 to get what? $7,500 for 5 years. And I have gas insurance and repairs that I need to figure out. So 10,833.33 plus 4,000. So if I want to figure out how much this old car is going to cost me all in all, oh man, I get this number. So I get this number. This is my old car for 5 years. Hold on to this number because this is like half the problem here. We still have to figure out what the new car is going to be. So same thing, we want to figure out mileage on the new car. So if we look at how we did our mileage on the old car, the new car should be really similar. We're still going to drive the 250 miles. Now my mileage is what? The new car, I think, says gets what, 45 miles per gallon? So instead of the 21, I should have 45 miles per gallon. And then the other thing we have here is the price of gas. So the price of gas is not going to change just because I buy a new car. That should stay the same. So our mileage should look the same. If we're trying to figure out how much gas we're using, how much it's going to cost us, it should look very similar. We're just changing one of those factors. And if we do that, we get 1944. It'd be 1944 for the week. And we do this again, going from the week to the year. It would be 1011. For the year, and then we'd multiply this by 5 to get 5 years. So 5055.55. 5055 point, probably rounded up a penny. So this should look pretty analogous to the thing that you did. We're just changing this one number for the new car. So this is gas. This is the gas or the mileage. The other thing that we had was we had insurance. So insurance for the new car was what, $400 per year for 5 years. So I think it'd be $2,000 in insurance. So 5 times, did I do that right? 400, yeah, that's it. And then the other thing was repairs. If we have a new car, we don't have any repairs, is what it says. So $0 on the repairs. So this guy's total for 5 years is going to be what? 705,556. And if they want to know how much money we saved, it's like what? This thing minus that thing, right? So 22,333.33 minus 7055.56. $15,277.77. Okay. Ooh. And so what is this telling me? What is this telling me about the cars, about the purchases? Am I going to buy that car?
Yes, you'll buy the new car.
What are they saying? 2033? Where are they getting that amount from?
I got 4,000 for the insurance for the new car. Oh, I think I'm looking at the wrong thing.
The new insurance is what? 400 per year.
New insurance is 800.
Insurance
It's,
premiums for new and old cars. Oh, the new is 800, the old is 400. Is that what it
Yeah,
is?
they phrased the question really weird.
They've
Was,
yeah, sorry. Mess that up. So this is 2000. That's why my numbers aren't matching what they say in the back of the book. Sorry. about that.
right. Okay. That's what. Okay. So that's what I got. 2,000 for 5 years insurance.
Yep, that's it. Sorry. I flipped them. This one should be the 2000, which makes this what? 20,033. And this one should be the what? 4,000. Are they also including the price of the car in here? They're also including the price of the car. That's what they're doing in here. Okay. which makes this what, 9,000? Is that what they're doing? Because yeah, they said the old car is 2033 is what the book is saying. And they said the new car is 25. Yeah, they're including the price of the car in there. Okay. I see what they're doing. So they're what they're doing is they're not looking at the difference of these two. They're looking at just the pure price of this plus the 16,000. So they're looking at the 25,055.56. And what they want you to do is they want you to compare the price of buying a new car and 5 years insurance and repairs. And so this is the car. This is the old car. And so which one would be cheaper? I mean, it's okay. This is an okay way to compare it, but this may not make your decision either, right? Like obviously the old car would be a little bit cheaper. Not by much. By like what, 5K? But with that said, like knowing that you're going to save what, like what? Or that a new car is only going to be what, $5,000 more expensive because your old car is going to need a bunch of repairs and a bunch of other stuff. Like depending upon what you're doing, you might just say, I'm going to go ahead and throw away 5K for 5 years, right? Like it might be worth it not taking your car into a repair shop every month. So there are other like considerations that you might want to make, but this is what they say in the back of the book. This is where they're getting their numbers from. Okay, so if you read the problem correctly, it's probably easier to work out. But I think most of this is sort of stuff that you should be able to do, right? If I tell you how many miles I am driving, you should be able to sort of figure out how much money and gas I'm going to end up spending from that. Okay. 43, you must decide whether to buy a new car for 22 or lease the car for a 3-year period. Under the terms of the lease, you make a down payment of $1,000 and have monthly payments of $250. At the end of 3 years, the lease car has a residual value of $10,000. Assume that if you buy the car, you can sell it at the end of 3 years for the same amount as the residual value. Is it less expensive to buy or lease? So do we want to buy or lease is the question here. So if we buy a car, they're saying what, 22,000 is how much we would have to buy it for, or lease the car for 3-year period. So if we lease it, we're going to do $1,000 down and a monthly payment of $250. And we want to figure this out for 3 years. And then we can sell the car for $10,000. If we buy it, we're going to sell it for $10,000 as well. So if we buy a car, we're going to buy it for $22,000, then we're going to sell it for $10,000. So if we want to know all in all how much we spent on the car for the 3 years, it would be what, the $22,000 minus the $10,000 we're getting back for it. I think this one would be the more straightforward one to solve. And this is what, 43? Okay. If we lease it, we're going to end up paying $1,000 plus we're going to pay $250 per month. And if we're going for 3 years, that's going to be a total of 36 months. make sure I'm reading it right. This looks like how much we're gonna pay for it under the lease, and then we can subtract the 10,000. Like we did with the buying. So 250 times 36. Is this what they're getting in the back? Let's see. So what it looks like is I'm gonna spend $1,000 down, 250 per month. Looks like you're spending 10,000 on it. What are they doing on this? Yeah, that doesn't make sense. They're not going to allow you to do that in reality. This does not sound like something they would allow you to do in reality, but maybe I'm wrong. If we do this, if we end up spending what, $1,000 and $250 per week, that's $10,000 we're putting into this car. Or $250 per month is what I said, right? For 36 months.
That, Professor, that was 20. That was 250 times 36 plus 1,000, right?
Yeah.
Okay.
Are they saying you can't sell it after you do this? Is that what you're saying? You can sell it. Okay, and if you want to buy the car, then you're gonna have to pay another 10,000. Is that what it's saying? Yeah, this question's kind of worded weird with the way they do their leasing. At the end of 3 years, the lease car has a residual value of 10,000. So if you're doing 1,000 down and you're doing 250 for 36 months, it looks like you're paying $10,000, and then it looks like you're gonna have to pay an additional 10,000 if you actually want to buy the car. But I don't think we're considering this. I think we're considering it to be sold, or like we don't have property or of the car anymore. In this scenario, we didn't have property of the car, right? We got rid of the car. So in this scenario, we're not buying the car. If we wanted to buy the car, we'd end up spending 20K on that car, I think is what it's saying. But that's not what's happening. If we lease it, we're gonna end up paying 10,000 total just to lease. Or like rent, you're basically renting the car, right? And so you lease it, and then at the end of your lease, you don't have property of the car anymore. That's what they're trying to compare in this problem. It's a little bit weird and a little bit oddly worded. That's the two amounts they want you to compare is the 12,000 versus the 10,000. So this is like we buy it and sell it. This is like we just lease it and we don't buy it, is what they're saying. Does that make more sense? Hopefully. Sometimes I don't know about their wording in these problems. Old stuff. I'm at 41, 43, 51. Now these are about choices. So now we want to look at a 15-week 3-credit college course, which requires 10 hours per week of your time and costs $500 per credit hour. Or you could work for $10 an hour. What is the net cost of the class compared to working? Based on your answer and the fact that the average college graduate earns $28K per year, higher than the average high school graduate, write a few sentences giving your opinion as to whether the college course is a worthwhile experience. So they're probably going to tell you college is a worthwhile experience, try to sell their own position on this one, but let's look at it. So you could take a 15-week 3-college course, which requires $10,000. So how much is this course going to cost? So if we're paying for the course, how much does the course cost? Not like how much are you missing in work, just like how much straight up is the tuition for this thing going to be? It's $500 per credit hour, and it is a 3-credit hour class. You want me to do some unit analysis? 500 per credit hour, and we're going to go what, 3 credit hours? So I think I'm paying this much in just tuition. The other thing they talk about is we're talking about a 15-week, 10 hours per week. So how many hours are you going to spend on this class? If we're going for 15 weeks and 10 hours per week, what's the total number of hours you're going to spend on this class?
So is that 10 times 15?
Yeah, it's it. 150, right? That's how many hours total you're going to spend in the class. And so how much are you missing out on work if you're spending 150 hours? This is the 10 hours by 15 weeks, right? So what are we doing? $10 per hour for 150 hours? So how much are you getting paid for 150 hours at your other job?
$1,500.
Yep. And so let me double check, make sure I am asking or answering what they want in the book. But I think when they ask for what is your opportunity cost, I think they want the actual cost and like the missed cost, right? How much are you missing by not working? What is the net cost of the class compared to working? So we're paying $1,500 and $1,500. I think they want $3,000 as their net cost. And let me double check and make sure that's what they're asking. This is 51. Yes. So they want the $1,500 in tuition plus the $1,500 from not working, right? And so for each class, there is a $3,000 net cost. What about the 28K? How does that compare to your net cost?
I mean, it's a drop in the bucket.
Yeah, pretty much.
$28,000 a year versus a $3,000 net cost for 15 weeks.
Yeah, so this is $3,000 net cost for each of your classes versus you're going to end up like 28K per year more. So I think that's what 28 divided by 3 is like 9 and some change. So you're making enough more to pay for what, like 9 classes a year or something like that. So there's a few different ways to look at it, but like 3,000 compared to 28 3,000 per class. Right, for how many classes do you need for a major? I don't even know anymore.
So I get 9,300.
You're doing 4 years with what, 4 classes each semester, 4, 8, 32. So this is for 32 classes. You're gonna end up paying 3,032 times. What is that, like 96,000 or something? Versus 28K per year as long as you go more than 96. How many years is that? 96 divided by 28. As long as you're living over like 3 years doing this, right? You like more than balances itself out.
So first, when I divided divided 28,000 divided by 3.
Yeah, I was just comparing the two to see how much larger this one is.
Okay.
So we do the 28 divided by 3, right? It gives us 9. So 3,000 is the net cost of your class. So you're covering at least what, like 9 of these classes per year in your salary. So like it's a drop in the bucket compared to the 28, like Lisa was saying, right? 3,000 is not a lot when you're making 28 extra, right? Even though it
Hey,
is
Professor.
class. So I don't know. Yeah, what?
My work schedule got messed up, so they scheduled me today from 2 to 10. So is it okay if I watch the rest of this video on YouTube?
Yeah, I mean, yeah, that's part of the reason why I put them up. So,
Okay,
good luck.
thank you.
Yeah, take care. 57. Laundry upgrade. Suppose that you currently own a clothes dryer that costs $25 per month to operate. A new, more efficient dryer costs $620 and has an estimated operating cost of $15 per month. How long will it take the new dryer to pay for itself? Okay, so if we want to talk about how much the old dryer costs, it's costing $25 per month. So we don't know how many months it's going to take for these things to balance out. That's what they want to know. But if this is $25 per month, how would you find its cost? It would be 25 times what? And it's not here. But if this is per, well, if this is per month, this would be multiplied by the number of months, right? And that's the thing we don't know. So there's a few ways you can do it, but the way I would do it, if it's a thing you don't know and you want to know it, let that be your X or your variable M. M is the number of months. So if we want to know how much this costs, it's going to look like something like 25M, right? And this is the cost of the old. The cost of the new. What is the cost of the new going to look like? So this is, we hadn't really gone over linear modeling, right? But this is totally just linear modeling sort of problem. We have 25 per month with no down payment. Now we have 15 per month. So this should look like 15M. And then a down payment of $620. So that should look like a payment of $620 that you're going to make no matter what. So this is sort of like a linear modeling. So this is sort of like your slope. So anytime we have something that is something per something, our slope is usually in some kind of units that are per something. That's why we're multiplying it by something. So the 25 says 25 per month. That's why we're multiplying it by the number of months. Same thing with 15. 15 per month, we multiply it by the number of months. It doesn't matter how many months we're going to have this thing. We're always going to have to pay the $620, right? The $620 is a down payment. So this is like your slope. This is sort of like your y-intercept happening here. If you look at things in the first quadrant, we're going to start out at 620 and keep going up, right? This other one starts out at 0, goes up, goes faster. I shouldn't draw them at the same angle. And they want to know where those things cross. Should be going up quicker. So I have a really cruddy sketch over here, but that's sort of what it looks like. So how do I figure out where these two things cross?
Could you subtract 15 from 25 and then just divide 620 by 10?
Yeah, so I set these two things equal to each other. Their costs are the same, means that these two would be equal to each other. These two equations, or not equations, expressions, sorry. So I want to know where these things are equal. So like you're saying, I would subtract 15m. So I want to solve for my m variable. I would subtract 15, which would give me what? 10m is equal to 620. And so my months is going to be equal to, I'm going to have to divide by 10 now. So if I divide both of these sides by 10, I can solve for my m, or the number of months. So it should be 62 months. They ask us months or years. What do they ask? How long will it take the new dryer to pay for itself? Okay, that's good. 62 months. Are there any questions about this, about how to do this sort of setup for the price? If it's 25 per month, it's 25 times the number of months. If it's 15 per month plus 620 down, it's 15 times the number of months plus that flat rate of 620. So like I said, this is linear modeling. If you wanted to go look up linear modeling, if this is like really confusing, that might be a good keyword to look up. But we want to know when these two things are equal to each other, when their cost the same, is the same as saying when are they equal to each other. So we set them equal to each other. We solve for m, which is 62 months. So after 62 months, these things will be equal. Okay, that was 51, 57. Suppose you're currently, that's the one I just did. 59, in each of the following cases, determine how much you would pay with and without insurance policy. Okay. So you have a car insurance policy with a $500 deductible per claim for collision damage. During a 2-year period, you file claims for $450 and $925. The annual premium for policy is $550. And they want it with and without insurance. I think without insurance is probably the easier one to figure out. So if I want without insurance, what numbers am I looking at? I think I'm looking at just the 925 and the 450. So if I don't have insurance, I'm going to end up paying everything I claimed. 1375, is that what I'm getting here? With the insurance, I'm going to have to pay $500 deductible per claim. So I'm going to have to pay, no, not that. And a premium of $550. So regardless of whether I file a claim or not, I'm going to have to pay the $550 premium. That's where I was trying to get at. I'm going to have to pay a $500 deductible per claim. So if this first thing is $450, guess how much I'm going to pay? I should be paying $450. So it's not reaching my deductible. I'm going to end up paying all of this. This is reaching my deductible, so I should only have to pay $500 for this, I believe. Did they really do this? 5, 10. So I'm paying $550. I'm paying $500 deductible per claim. Oh, I'm paying $550 twice. Shoot. I'm paying that premium 2 times because I'm doing this over 2 years. That's what's happening. Is that getting me the amount that they're doing 2050 in the back? Is that still seems fine. So if I do 550 plus 550 plus 450 plus what 500? No, that's it. It should give you 2050. So I don't know what their lesson on this is besides don't have insurance, but it's probably not a good lesson. Usually if you have insurance, it's not going to be more. Like, that's kind of silly. But the insurance premium is $550 per year or something, and they're making claims less than that. So that is what part A. Part B says you have car insurance with a $200 deductible. So I think doing without is probably the easiest way still, right? Doing without, we're going to pay the $450 and we're going to pay the $1,200. So I should be getting paid what, $1,650 is what I'm going to end up paying without insurance. So with insurance, I'm going to end up paying my premium for 2 years. Have to do that twice over 2 years. This has a deductible of $200. So for this first one, I'm going over my deductible. So I'm only going to pay $200 out of that first one. For this one, I'm definitely going over my deductible. So I'm only paying $200 out of that second one. So this one, I think insurance might end up saving me a little bit. No, still going over by $50. But I think what they're trying to get at with these problems, and they say it in part D, is like, what is the difference between your premium and your deductible? So each of these are premium went up here, but our deductible went down, right? Same thing here, our premium is going down, our deductible is going to end up going up. So there is a sort of trade-off between how much you pay for your premium and how much you pay for your deductible. So let's do the last one without. We're going to end up paying $200 and we're going to end up paying $1,500. So without insurance, the last one should be $1,700. With the insurance, I'm going to end up paying that premium twice for 2 years. So my premium was $300. And my deductible is $1,000. So I'm going to end up paying $200 here. I'm going to end up paying $1,000 on this one. All in all, I think I'm going to end up paying what, 18? $1,700 and $1,700 without, and $1,800. Yep. All right, and so explain why lower insurance premiums go with higher deductibles. Because they got to make their money somehow, right? If we don't get more money from our deductible over here, we got to get more money from our premium, right? That's kind of how we did with the insurance. So this is our premium. This was from our deductible, right? This was from our premium. This was from our deductible. So they got to balance this out somehow. So if they take less from the premium, they're going to be taking more from the deductible, right? They're not losing, they're not in the insurance game to be losing money, basically, right? So anytime we did the insurance, we figured out the premium and we added it to whatever we had the deductible and cover. Okay. And I think we got one last problem in the section. Health costs. Assume that you have a relatively simple health insurance. The annual deductible is $500. Office visits require a copayment of $25. Emergency room visits require $200. They give you all this information about copayments, about your premiums. The annual deductible is $500. And then the insurance company is going to pay 100% of all costs after your deductible. So a lot of the things they kind of write in here, I feel like they're insurance policies that they figured out for a math book, if I'm being honest. Like, I don't have insurance this great. If that's what y'all have, I'm kind of jealous. Most insurance is not paying like 100% of stuff after your deductible, from what I've seen. But there are some out there that do. So we want to determine what your healthcare expenses are if you do and do not have insurance. So if we don't have insurance, I think that's the easier one to probably figure out. So let's do that one first. If we don't have insurance, we're going to end up paying what, 100? These are kind of blurry, but 580, 100, 6,500, 100, and 840. I think when I add everything together, I'm getting 8220. And this is 62. Oh, they're not going to have it in the back. Okay. And that's just taking a sum of all your expenses. So you're going to end up paying your total cost. You're going to end up paying that all out of pocket. The other way, are we doing, it looks like we're doing a 1-year period. So we're doing this for a year. So if we're paying a premium of $350 per month, what I'm going to pay for the year is going to look like what? 350 times 12. So this is my premium for the year. I'm also going to end up paying at least $500 in the deductible. All these are going to total up more than $500. I'm going to end up paying that full deductible. This is my premium. This is the deductible. And the other thing I really need to figure out is what my copays are. So they're going to charge me a bunch of copays for everything that I have here, I think. My office visit copays are $25. So if I write out my copays right here, it might help. My emergency room visits are $200. My office visits are $25. That's the same thing. $25. My surgery copay is $1,000. And emergency room, that's another $200. Woo! So those copays, I think, are going to rack up pretty quick. 25 plus 200 plus 25 plus 1,000 plus 25 plus 200 is what it looks like. $1,475, I believe, is what I'm paying. And so if I want to add these together, this is what, 4,200 plus 500 plus 1,475. So if I'm adding these three things together, I should multiply these first. I should end up getting 6,175. And so I think insurance is finally paying off in this example. That's what is happening.
That was 8220 minus 1475.
Where are you at here? I'm not subtracting anything. I'm just adding these three things.
Oh, okay.
My premium, deductible, and my copays that I'm paying with my insurance. So part B was without insurance. So we're just adding all our expenses without doing any kind of discount on them, right? We're just adding these things straight through. Part A was asking about insurance. So we're going to end up paying a premium. We're going to end up paying this premium 12 times. We're going to end up paying a deductible of 500. Deductible of 500. So we're going to end up paying that full 500 of the deductible. Our bills are obviously going over 500. And then the other thing they make us pay is this thing called a copayment. And so I'm adding those three things together to find the total with insurance. Okay, so 4B, a little bit of a shift in the direction. So we're still doing finances. Here we're doing simple interest and compound interest. So calculate the amount of money you would have in each account after 5 years, assuming the account earns simple interest. So if we deposit $800 into an account with 5% annual interest rate, how much money am I going to earn per year? So how much interest would I earn per year on this account? So we got 800 down and a 5% interest rate.
Would it be 1,000 after 5 years?
I don't know, you did too much work in my brain. So 0.05 times 800. Yes. No, wait, no. We were going to do what, 5%? Yes. You're doing the formula is what you're doing. 5% of 800 will give you what? $40. The amount that we will get after 5 years will be 200 for 5 years, right? And so this is 200 in interest. So if they asked how much interest we would get for 5 years, it would be the 200. But they want to know how much money we have. So we started with 800. We're going to add 200. I believe this is getting $1,000 from. Does your book give you a formula? I don't remember the book gives you a formula for the principal. Sometimes they give those formula. It's like APRY, APR. One plus APR times Y or something like that. Sometimes they'll give you that formula, sometimes they won't. But what we're doing is we're looking at our annual interest rate. And for 5 years, we're going to earn $200 on it. And so we're going to take that $200 and we're going to add it, back to our principal. What does it say? Plus your principal times. We do some distribution with this. So if I'm being honest, I don't think I give you a simple interest formula. I think I just make you crunch these things just as they are. So we want to find the interest for a year. If they give us multiple years, we have to multiply it by however many years they give us. We have to take this amount that we earned and we have to go add it back to our principal to find our accumulated amount. So this one says use the appropriate compound interest formula to compute the balance in each account after the stated period of time. So 4,000 is invested in for 20 years with an APR of 6% and monthly compounding. So again, looking back, looking through 4B, we had a few formulas. We had like this compound interest formula. Can we see it? Maybe not. This compound interest formula, A equals P times 1 plus APR to the Y. This is if interest was paid for once per year. So this one is not going to work here. The one that we need is the other one that's a little more complicated. It looks basically the same, except we take our APR, we have to convert our APR, and we have to convert the number of compounding periods. So this, if it's compounding more than one time per year, we're going to use this formula. This is the sort of formula I want to use. A equals P. 1 plus 8. So the first sort of thing is knowing which formula you're going to use for this one. So the key words is that we're using compound interest. And the other thing is you want to look at the intervals of compounding. So the other key word here is monthly. It's telling me I'm going to do it n times per year, where my n is what number?
12.
Yep, so I should put in 12 for my n. I am just filling things out. So A is my accumulated amount. That's the thing I want to figure out. Whew.
Bless
Using
you.
type.
Thank you. Okay, anyway, so this is the amount. The next thing is my principal, which is the amount I'm starting out with, which is the $4,000. This is 1 plus my APR. I have to convert that to a percentage. So that is 0.06. I have to divide this thing by n, which is 12. 12 times, what number am I doing now?
20.
20 years? Is that what I'm doing?
67, right?
20 years right there. Okay, sorry. Yeah. My head's still spinning a little bit from that sneeze. Okay. If you can get this set up, if you can understand what the problem's asking you and you know the formula to plug it into, and you plug it into your formula, like this is a big step in the problem. This is a big portion of the problem. 0.06 divided by 12. The next thing is being able to do these things in the right order, doing PEMDAS, right? There are these things. Probably step by step, and then I'll try to speed things up stepwise. 0.05 to the 240. And if I multiply this by 4,000, okay. And then there was really only one other formula we had in this section was the PERT formula. This makes sense. We start out with 4,000, do 20 years at 6%, end up with 13. Well, I don't know, probably. It's not so obvious, maybe. The other thing, so annual percentage yield. This is another thing we talked about in this section. I almost forgot about this guy. So we want to figure out the relative change that is happening over 1 year. So if I start out with a bank that offers an APR of 3.2 and it's compounded monthly, we want to know sort of like what formula we're going to use. The key word here is I see compounded monthly. that's the same thing as monthly compounding. It is the same formula that we used previously. So we want to figure out the annual percentage yield. And so just looking at this, my annual percentage yield, is it going to be more or less than this thing?
More?
It should be more because we're compounding it monthly, right? So this APR should actually go up a little bit, right? We're actually earning a little bit more than that. Okay, so we're earning a little bit more, so let's do it. So we're going A, we don't know what our accumulated amount is. Our principal, that's what they don't give us. Okay. Do they not give you principal? We could start. So we need to figure out a principal. If they don't give you one, you can choose kind of whatever you want, to be honest. So I think a really easy thing to pick would probably be 100. And if I pick 100, 1 plus my APR is 0.032. I want to do this per month, which is 12. I want to do 12 months, and I want to do this for a year to figure out what I end up with. Note, I subbed in P being 100. And so 1 plus, and I'm getting 1.0267, 1.0267, somewhere in there. And I have to raise this to the 12. So again, if you're a few cents off with your solution, it's not a big deal. But when I do things, I typically don't round till the end. I try to get them as accurate as possible. So this is going to give me something like 103.25, I think is what it's going to give me, 103.25. And so what is this telling me? After 1 year, if I start out with $100, I'm going to end up with 103.25. My end. So how much did this increase?
$3.25.
Exactly. So we want the relative increase. So that is the absolute increase. If we want the relative increase, what are we going to have to divide this thing by?
100.
Yeah, and that's part of why I picked that for my P, right? So 325 divided by 100. Would you buy it if I just jumped to the 3.25%? So how much is this APR or the APY? Sorry, this would be the APY here, right? Would be a 3.25%. So annual percentage yield is like asking if we go for 1 year, what would my APR be, right? Or what is my relative change? So what we do is we plug it in for 1 year. We know this is 12 months. We know our APR is 3.2%. The only other thing that they kind of give you an option on is this P, right? So if you wanted to let it be 1, you could let it been 1. It's probably easy to do it 100 here because I know in the end I'm going to have to do a relative difference. So if I end up dividing by 100, it makes it really easy to solve this thing. So This was just knowing where I was going to go and planning ahead a little bit. Okay, but that's how you find APY to the nearest 0.01%. 3.25% should be close enough. What do they say? 70? Oh, that's 72. It's not going to be in the book anyway. Okay. We got 4 more. Okay. Planning ahead, how much would you deposit today into each of the following accounts in order to have 25K in 8 years for a down payment on a house? Assume that no additional deposits are made. So I'm putting the cart before the horse probably a little bit here, but this section, when we do compounding or we do simple interest, these accounts and these formulas that we're using is like we're putting money into the account and we're just going to leave it there, right? And I think in the notes I gave you, what's that guy's name now? I can't remember his name. The guy that fell asleep.
Is it the Euler guy?
No, I was the made up guy that fell asleep for 500 years. Rip Van Winkle, that's his name.
Yeah, Rip Van Winkle.
Yeah, it was an old literary figure. But this is kind of like the Rip Van Winkle effect, right? We're going to put money in there. We're not going to keep putting payments. We're just going to fall asleep. There's an episode of Futurama where Fry ends up getting a lot of money. Same concept, right? He put a lot of money in there to begin with. He did not touch that account. So these, we're not touching the account. We're only putting money in at the beginning. When we get to 7C, we're going to start doing savings accounts. So we're going to start making payments. So this is probably kind of a stupid way to start saving money, if I'm being honest. Usually when you start saving money, you make a down payment and you start making payments to save money. But that's not how they're doing it here. So when we get to 4C, it will be we're making payments. That's the big difference. Is we introduce this concept of making regular payments. And things get a lot nastier and fuzzier with the formulas, but they give you a formula, so it's not like you have to derive it on your own, right? So how much must you deposit today in each of your following accounts in order to have 25K? So the formula I want to use probably looks like this: AP1 plus APR over N to the NY. I would almost guarantee you this is the formula I'm going to use for most of these. And right here we see 83, an account with monthly compounding. So the second I see monthly compounding, I hope this formula pops in your brain. If we're doing monthly compounding, we have to do it here. And just a quick recap. This was the first formula that we kind of introduced to the Y. So this was if it was compounded once per year. And this was the first formula that we introduced in the notes. This is actually the same formula if we just let N be 1, right? But they kind of give you this formula to start you out with. And the other one was the PERT formula, P equals E to the RT, which is APR and Y in our book. And this was continuously compounded. So this is compounded N times per year. This is once per year. And this is kind of like infinitely many times per year, right? Infinitely many, whatever the heck that means. We call it continuous. Right, is what the word that we use. So it reaches a sort of limit when it reaches infinity. It's what we talked about in the notes. So back to this one. The second I see compounded monthly or monthly compounding, I know I'm using this formula. I know my principal. I don't know my principal in this one. So that is what we want to figure out. But they say in order to have 25K. So this 25K is not our principal. That is going to be which one?
Our A?
That's going to
Annual.
be, yeah, that's going to be your accumulated amount. So what they're saying is that this is 2,500. My principal is the thing I want to know. I have 1 plus my APR, which is 0.06. I'm dividing this by N, which is 12. My N is still 12 up here, and I'm doing this for how many years? Looks like 8 is what they tell me. So there are a few ways to do this. This is P times a bunch of junk. If you wanted to just throw this thing underneath this thing, you could do that. I think I'm going to do this a little bit piece by piece. So this is 25,000. I want to simplify this down a little bit. 0.06 over 12. And then we're going to add that to 1. It should be 1.005 in the parentheses here. So I'm going to divide, I'm going to add. This should be to the, what, 96 power? 8 times 12. All right, so I'm going to do 1.005 to the 96. This is like 1.61414, somewhere in there, 61414, something like that. And now the final step is I have P times this number. If I want to solve just for P, how am I solving for P?
Divide.
Yeah.
Divide by this crazy thing right here, 61414, whatever the heck this is. And again, if you round, you might be a few cents off, but it should be pretty close. 15,488 and 09. It should be 10 cents when I round it up. There we go. Does this make sense with what our problem says? So if we start with 15K, we want to end up getting to what, 25K? Okay. So this definitely should be less than the 25K, right? The 25K should be the accumulated amount. So we're starting out with 15K. We're waiting, what, 8 years, I mean, monthly compounding. Do we answer everything they wanted? How much?
Professor, on the finding P, I get 15488.123.
That's good. Yeah, so you're 2 cents off. That's good.
Oh,
It's just a rounding error at that point.
okay,
You're like 2 cents off on something that's 15K. I don't think I'm going to notice it.
okay.
All right, as long as you're in the ballpark, as long as you give me something like 15, like 15,500 is probably even like pretty good on this one, right? Like as long as you're in the ballpark, as long as I see that you're doing the work correctly. That's the other thing. Like some people are like starting to turn in stuff that's looking more like an answer sheet than it's looking like homework. It's like, I got to see some work. I got to grade work. I already know what the solutions manual looks like. I can order it. I can look at it. I don't want to see a solutions manual. That was what, 83, 87. I think we've got 3 more problems. How much must you deposit in each of the following accounts to have 120K college fund in 15 years? Assume no additional deposits are made. So this is the same sort of problem that they're trying to give you. So the keywords here is to notice compounded quarterly. And we have an option of those 3 sort of functions or formulas that we could use. So we're going to use the same formula that we've been using. And if they say compounded quarterly, what is that telling me?
You're gonna divide by 4?
Yeah, my N is equal to 4, right? An APR of 2.85. And what is it? They say we don't know the principal, but they're giving us an accumulated amount of what, 120K to figure out? Want to make sure you can plug in stuff to A and figure out P is what they're trying to get with these two problems, right? We can use this formula, we can solve for P. 1 plus my APR is 0.0285. Did I do that right? 1, 2, yep. And I want to divide this by quarterly means 4. And this is to the 4 times something. They want to do this for 15 years is what the problem says? Yeah, 15. So this setup, if you can get this thing set up like this is probably like half credit, right, for your problem. It's a good portion of it. Can you get this thing set up correctly? Are you using the right formula, and do you understand what's kind of happening here? 120K over here. This I can clean up a little bit. If you wanted to move like this entire thing underneath here, because you're going to end up crunching this and then dividing, right, is what's going to happen. You could absolutely solve these things for P. You could solve this formula for P and maybe save a little bit of time. I didn't do that, so let's just do it. 0.0285 divide by 4 plus 1. If I look in here, I'm going to add 1 to 0.007125. It's going to become 1.007125 on the inside. 4 times 15 is going to give me what, 3060. So I'm going 1.007125 to the 60th. So again, like this is one of those things that's going to depend upon what your calculator looks like and what sort of accuracy it has, but you need to find something that will be fairly decent. I don't know how to say it right. Something that's not just going to round it to like 2 decimal places or something, right? We need something with pretty good amount of decimal places to do. So I'm taking 120,000 and I'm dividing it by that crazy number. So it looks like this is the principal that I'm getting. So 78,375.20 if I round that thing up. $87, let's say 78,375.20. Yep, that's it. Any questions about these, how we're doing these? So these are a little bit backwards from like the way that this equation is set up, right? You do have to do a little bit of back solving on these. Not a whole lot, but a little bit. Okay, so small rate differences. The following pairs of investments plans are identical except for a small difference in interest rate. So compute the balance in both accounts after 10 years and after 30 years and discuss the differences. So Chang invest 500 in an account that earns 3.5% compounded annually. Invest 500 in a different account that earns 3.75 compounded annually. So the keywords is I see compounded, so I know I'm going to use one of my compound interest formulas. The other thing I see here is annually. So if you want, you could use this one again. But since it's compounded annually, we have a very specific formula for things that are compounded annually. And it is the one that looks like this, but it is a little bit simpler. So you could use this one and let n be 1. You will get this formula right away, as long as we let n be 1. Our APR divided by 1 is just going to be our APR. 1 times y is just going to be the y. This was the first formula they gave us. This is if it's compounded annually. So Chang is investing 500. It looks like Chang, Math Professor Chang versus Keo. So Chang, if we want to find his, our accumulated amount, we know a principal of 500. 1 plus, and my APR on Chang is 0.035. And we're doing this to the Y. So they want to do it for 10 years, and then they want to do it for 30 years, is what they say in the problem. So first, we want to do this to the 10th. And then the other thing we want to do is we want to do this to the 30th. $1.035, if I raise that to the 10th and then multiply that by 500, I'm going to squeeze it in right here. But this should be giving me 705.30 if I round that up. So now is definitely the time to do a calculator check, right? Make sure you have a calculator. Make sure you have a calculator that you can throw these things into. Make sure when you're doing these crazy exponents on your calculator that you're getting the same solution that I'm getting, right? And if you're not, like, you can come talk to me during office hours, come talk to me sometime. Try to get your calculator in order. 1403, 40 if I round this up. Okay. So if we're looking at this thing, and maybe this is an observation we can make, we're going from 500 to what, 700 here? So over 10 years, we get netted like 200. So if we're going 200 every 10 years, people might think if we're going for another 20 years, that should go up 400. This is going up more than 400, right? And part of that is because we're doing exponential. So the further we go, the more it's going to increase. So you might notice things like that. Keo, how does his differ? He's going to do 500. He's going to earn a little bit more than this guy. So instead of 0.35, 0.035, 0.0375. So the only thing we're changing on Keo's is the APR. So first one, we want to know what this is doing for 10 years to the 10th. Multiply this by 500. This should be giving me 722.52. And I also want to figure out what his is going to be for 30 years. So the same number, but now I'm raising it to the 30th and multiplying it by 500. This should give me 1508.74. And hopefully, like off the bat, hopefully you realize Keo is going to be making more money because he has a higher APR, right? How does that compare to Chang? So we're not talking about much higher in our APR, right? We're talking about like 0.25%. It's not a lot higher, but even at 0.25%, when we go over 10 years or 30 years, it makes a little bit of a difference, right? So this guy is making almost $20 more here. He's making almost $100 more here. Again, that is over like 10 and 30 years. So it did take him quite a bit of time to catch up. But your APR rate, the higher your APR rate is, the more money you're going to make. The more compounding periods you have, the more money you're going to make, right? So they're wanting you to make these sort of like, what do I want to say? Connections, I guess, between what's being said and what you're crunching.
So
I like
Professor,
it.
all we changed is the interest rate on both of those.
Yes,
Oh,
it's just the
yeah,
interest
same.
rate. It's still just this formula. We're just plugging in different numbers for our interest rate. Chang versus Keo, we're doing it for 10 years. We're doing it for 30 years. I like money. So suppose you want to accumulate 120K for your retirement in 30 years. You have two choices. Plan A is to make a single deposit into an account with an annual compounding and APR of 5%. Plan B is to make a single deposit into an account with continuous compounding and APR of 4.8%. How much do you need to deposit in each account in order to reach the goal? Ooh, should I ask which one's better beforehand? It's hard to tell, to be honest, if I'm being honest. I don't know if I could tell right off the top. You typically, continuous compounding is better than compounding what, per year? The more times we compound, continuously compounding is like the most times you can compound. It's like you're compounding infinitesimally times per second, right? You're just like continuously doing it. It's like, it doesn't even make sense in reality. It just makes sense as a conception sort of thing, right? To compound something infinitesimally many times. But this is the ideal sort of situation. The thing that might throw it off is that this APR is less than that one, right? So we have two different things we're using. I think we're using this formula, 1 plus APR to the Y. I believe we're using that formula and the PERT. P equals E to APR Y times Y. And so this is saying we want to reach 120K. So 120K, we've done a few examples, but that is our accumulated amount in this example. And so the first one, they don't know the principal. We want to know the principal. Plus my APR, my first one was 5%. And they want to do this for 30 years, is what they say? Yeah, 30 years. So we've done a few examples like this, but if I have 120K over here, have P, and I want to figure out what 1.05 to the 30th. I'm going to give me something crazy like 4.3219, somewhere in that ballpark. And so when I divide 120K by this crazy number, my principal should be around somewhere around 27, 765, 29, something like that. And this is if I compounded it once per year for 30 years, I would have to start out with what, 27,000. So if you got an extra 27,000 laying around, just go throw it in the closet in an account. The compounds once per year. 30 years later, after you get grandkids or something, after your grandkids have grandkids, you'll have that 120K. And then we'll have to count inflation and figure out it's probably worth less, right? But anyway, this is the problem here. The other one is a continuously compounding. So the second we see continuously compounding, this is the formula you should think about. It is the PERT formula. The PERT formula keeps things silky, smooth, and shiny. Does anybody know what PERT is? Is that just I said it one time in a class and they just like,
I
sometimes
think
you
there
might,
are enough of us in here that are old enough to get that reference.
yeah, they still sell it though. I just like, it's on the shelf.
Do they?
I'm pretty sure. Maybe I'm wrong. I could be wrong. But PERT used to be a shampoo. I'm pretty sure it still exists. Sometimes people call
Bird
it
is
PERT.
gone, isn't it?
I thought it exists. PERT Plus is what it is. I thought it still existed. Maybe I'm wrong. I'll have to go look it up. But sometimes they will call this PERT. Sometimes they will say this is, instead of APR, this is your R, your interest rate. T, it would be your time in years. So sometimes you might see this written out as your PERT formula. So this is anything that is, anytime you see that word continuous, like this should be the first thing that pops in your brain. Continuously compound. Think PERT. You gotta keep it silky smooth and shiny, just like my hair. So anyway, compounded once per year, this should be the first thing pops in your head. Compounded more than once per year should have the things with the ends in it, right? Continuously compounding, here we go. 120K is my accumulated amount. Principal is the thing I want to know. This is E to the APR, which now we're doing 0.048. And I have to multiply this by my years, which is Y, which is 30. So I'm doing 0.048 and I'm multiplying that by 30. I'm getting 1.44. 120,000 equals 1.44. And so this is the thing you're gonna like absolutely need a calculator on. We're gonna have to evaluate E to the 1.44. So it is the lowercase e on your calculator. There is a difference between uppercase and lowercase. Remember, the uppercase is things like scientific notation. The lowercase, and if you notice, it is the opposite of the natural log. So it is like the opposite operation of the natural log. We're going to get something like 4.22 in that ballpark. So P times 4.22, somewhere in that ballpark, in 120,000. So 120,000 divided by like that number should give me 28,431.33. And so this is the principle I would need with the continuously compounding. So which one is better, I guess, is what I'm asking here.
Continuously compounded one?
Ooh. So this is the money you're putting in. So if you had to put money in, which one of those would you rather put in?
I'd rather put in the yearly.
I'd rather put in this 27. So if this was accumulated amount, you'd absolutely be right. It'd be the higher one. But this is our principle. We can put in 27 or we can put in 28. I'm going to want to put in my 27K to reach the 120. So this one is definitely cheaper. It is definitely a better account, right? And so I think they're trying to get at something here, maybe. We're talking about like 0.2% difference between 4.8 and 5. But the APR tends to make maybe a bit of a larger difference in our final amount than the compounding periods. So they both affect it, but like your APR might be a little bit stronger, right? Just a very small difference in the APR makes a big difference in the amount.
Ask a semi-related question.
Sure.
Why are they called transcendental numbers? So they said that the E and pi are examples
Transcendental.
of transcendental numbers. I figured you might know.
I would say they're irrational. I'm
Well,
not
they're
sure.
irrational, but I guess the book says they're also examples of transcendental values.
I would say irrational. I don't know why they're saying transcendental. I'd have to look at what they're talking about in the book.
Okay.
What do they mean by transcendental values? Believed in numerous values. How do they mean? They're
Well,
essential
I think
values.
it's like a specific type of irrational number,
Uh,
but
that's a good vocabulary question. I wouldn't know without looking it up, to be honest.
okay.
I don't if it's because things are based on that and because things are defined around it, maybe. Because like pi, right? We can define pi. You can actually define like pi as like half a circumference or something like that. You can actually
Mhm.
start defining things based off of pi, right? Even our circumference is like defined off of pi, right? It's just one of those it's one of those numbers that pops up in nature over and again and again. And like the lowercase e, right? If you want to do e to the first on your calculator, it is an actual number.
Hmm.
E to the 1 is like 2.718, right? And it keeps going on and on, doesn't have a pattern. It's easier just to use e as a unit in itself, just kind of like it's easier just to use pi as a
Right.
unit and say like 3 pi's or something like that, right? And so I think in the same way, that might be what they're talking about with the transcendental. It's irrational because
Okay.
irrationals are things.
Because it keeps going.
Yeah, that's like a consequence of a rational number is something that can be written as a ratio, like a over b, like 3 over 4. And so if it can be written as a ratio, it means it like either terminates or it has a repeating pattern, right? So this
Mhm.
repeating pattern or terminating decimal is actually a consequence of it being able to write it as a number over a number. Like e and like pi, we can't write as a number over a number the same way we can write things like this. So yeah, it's irrational, and it's irrational because it doesn't repeat, right? It doesn't have a repeating pattern. But I think I'm already like 10 minutes over class right now. So if y'all need to get somewhere, you can absolutely
Sorry.
go somewhere. Yeah, y'all are fine. I'm still here to answer questions. If y'all have questions, I will answer them. But I think that is the final problem that we have to do, right, for homework.
Yeah.
Transcendental numbers. God, that's a good one. Transcendental values is what they said.
I think so. I can check my notes really quick. Yeah, transcendental numbers. E and pi are both examples. It was in like the section where it was talking about Euler.
Well, good thing is that that's definitely not on your test, right? That would be in 4B. It would be in.
No, I wrote it down because I was like, that seems like a question that might be asked, but.
I mean, that is a good
Okay,
question.
well, I'll look into it.
All right.
Yeah, if you figure out anything, I guess.
I was trying to see what they were going to say in this section. If you want to hold on
Sure.
a second. What does it say? I guess I could share it, right?
Mhm.
Playing ahead. Should be.
It's by the continuous compounding.
This
Right there.
historical note.
Historical note.
Yeah, it's weird they don't give a definition of it. They just say it's a transcendental number.
Yeah, this book kind of sucks. I know you didn't write it, but please don't take offense.
I know there is a crazy sort of
I
thing.
mean, like it's good for certain things, but like the wording on a lot of stuff is just like really confusing.
Yeah, I'm not a big fan of the way they always word stuff. There is Euler's identity, which is like crazy as heck, and it relates like 3 different things. If you want to look at Euler's identity, that might be why they call it the transcendental, because like we use e to the I pi plus 1 equals 0. This is like relating like three things that like are totally different. So when we talk about E and Euler's number, we're talking about things that are like kind of the opposite of natural logs. And so it's really kind of crazy because you learn these things separately in your math class. Like E, we learn this on a separate day that we learn imaginary numbers is a separate day that we learn pi. So I don't know if maybe this is why they're calling it transcendental, because of his identity that we're able to like transcend those three concepts. I don't know. Just being honest, I really don't know why it's called transcendental values or what they're trying to emphasize there with that word. I would have to look it up and look what they're talking about, see why they're calling it that.
Wow.
Yeah, it's kind of weird they throw the word out there and don't really tell you what it means.
Hey, Professor, I was trying to get that last problem that you had, not this one here, well, this one as well, but I'll catch it on the video. But the one that's really troubling was the one where, what was that? That was in 4A. It was the, hold on. Where are you?
I didn't do it.
Well, anyway, I can't find it right here, but
I thought I hit stop on it.